In this video, I'm going to show you how to calculate the power or the current used by an appliance. Now, power is the amount of energy used per unit time. So power, amount of energy used in a certain amount of time. So that's what we mean by power. Okay, the units of power is the watt. Okay, and we refer to when we are looking at the energy consumption of an appliance, we're talking about the wattage of that appliance. So power can be calculated by looking at the current used by the appliance times the voltage um, going into the appliance. So this would be the power in watts, and that would be the current in amps or amperes, and that would be the voltage in volts. Okay, so that takes care of the background that you need to calculate the power, or if you have the power, we can calculate the current. Okay, so you see on the right side of the screen over here, I have 4 different labels, manufacturer labels from different appliances. The first label is for a vacuum cleaner. So let's title this vacuum cleaner. And the vacuum cleaner label, if we read it, it says that it operates at 120 volts, 60 hertz. That indicates that it's AC current. And it looks like it's operating at 12 amps. So there's 12 amps of current flowing through the device. So let's write down that information. We need to know the voltage. Volts is equal to 120 V. Current I is equal to 12.0 amps, and we want to figure out what is the power. So power is equal to I times V. So power is equal to 12 amps times 120 volts. So take our calculator, and we have 12 times 120 is equal to 1,440 watts. So that's the wattage or energy consumption of our vacuum cleaner. Okay, so now let's take the next label right here, have a look at it. So this is a label for a light bulb, and it actually tells us what the energy used. It says it's 13 watts. It's actually energy per unit time. So it's 13 watts. And it also tells that tells us something about the brightness of the light bulb. So here we already have the wattage, so we can figure out what the current is going through that particular light bulb. So let's put down light bulb. And our wattage, P, is 13 watts. Seems to me that's probably one of those twisty light bulbs, the CFLs, which is compact fluorescent light bulb. Power is 13 watts. Now, all electrical appliances that we plug into the wall have a voltage of 120 volts in this country. So what we could do is we can calculate what I is. So I know that P is equal to IV, so that means that I is going to be equal to P divided by V. I is equal to 13 divided by 120. So 13 divided by 120 is equal to 0.103 amps. Okay, very low current going through that light bulb. Those light bulbs are very energy efficient. Okay, let's go to the next one. Right here we have a food steamer. So food steamer. And what does the label say? It operates at 120 volts. That little squiggle line right there says that it's AC. That's what that means. So our voltage is 120 volts and 60 hertz. That's another indication that's AC current, as opposed to DC current. DC current is battery, battery operated. And it says it's 900 watts, so P is equal to 900 watts. So I guess we can calculate what the current is. So P is equal to IV, or current is equal to P divided by V. So that'd be 900 watts divided by 120 volts. So 900 divided by 120 is equal to 7.5 amps. Wow, that's actually, that seems like a lot of amps compared to that light bulb right there. Now, the light bulb that we calculated earlier is only 0.1 amps, and this is 7.5. You know, that actually makes sense, is because it takes a lot more energy to use a food steamer than to use a light bulb. And if you go back to our vacuum cleaner is 12 amps, a whopping 12 amps. And that also makes sense, is because it takes a lot of energy to operate a vacuum cleaner. You know, just look at that wattage. It's 1,440 watts compared to 13 watts to operate the light bulb. You know, it's a great difference. Okay, so let's look at this last label right here. It's an AC adapter. So your laptop computers use an AC to DC adapter. So what this label tells us is that our input here is 120 volts AC at 60 hertz, and it's 9.5 watts. Now the output, what actually goes into the appliance, in your case, it would be the laptop, that would be 12 volts DC at 500 milliamps, or 0.5 amps. Okay, so let's look at what the input would be, because that would be actually the energy that you're utilizing. And we'll talk about the output later. So AC adapter. Okay, so our input, what do we have? We have volts is equal to 120, and we have wattage is equal to 9.5 watts, and let's figure out what the current is. So current is equal to P divided by V, so that would be 9.5 divided by 120. So 9.5 divided by 120 is equal to 0.079. 0.079 amps. Okay, so that's what goes into that adapter. So what comes out of the adapter? Well, according to the label, our voltage is equal to 12 volts. Our current is equal to 500 milliamps. Now I need to convert that to amps. So that's divided by 1,000. So 0.5 amps. And our power, that's what we want to figure out. So power is equal to IV. So that would be 0.5 times 12, or 6 watts. Okay, so if you look at, there's a couple of ways we can look at this. We can say that, okay, look at this. Our wattage in is 9.5, but we're only getting 6 watts output. So that means some of the energy that we're using per unit time, energy per second, some of it's being lost. And we know it's being lost because if you've ever felt that AC adapter for your laptop, you know it gets hot. So some of the energy is wasted, um, not intentionally, but that's just the way the device operates. So some of the energy is converted to heat, and it's just too difficult to prevent that from happening. It's just not worth um, designing a device that takes use of all the available energy.